So let's talk about the parts of this thing. So this is a radical. Radical means that root symbol. It may not always be a square root. We can also take cube roots and fourth roots and fifth roots and sixth roots and so on and so forth. So you may have never even seen a number written there before where that n is, because most of the things you've seen are square roots. If it were a third root, for example, like the third root of 8, that's asking what number times itself 3 times gives you 8. Does anybody know? 2, yeah, 2 times 2 times 2 would be 8. So that would be like the third root. Yeah, Selena, we're not going to do the rest of it. I just wanted to go up to those 3 problems. That little number, if it's there, is called an index. I-N-D-E-X, index. The square root symbol itself is called a radical, or the root symbol is called a radical. What does that symbol look really, really close to? Yeah, like the long division symbol. So please make sure when you're drawing this that you include this little like check mark that's at the front of it, because that tells me that it is a root and not a division symbol, long division symbol. And then the number underneath the radical is called the radicand. No, I did not make that up. That is a real word, radicand. So again, if there is no little number that indexed, we assume that it is a square root. Just like when you have an x with no coefficient, you assume that that coefficient is 1. When there is no index, we assume that it is a square root. So let's list the first 12 perfect squares. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4, 16. 5 times 5, 25. Keep going. I'll go all the way up to 144. You're multiplying the same number times itself. That's how we get perfect squares. Multiply the same number times itself. So the rest of them should have been 36, 49, 64, 81, 100, 121, and 144. So those are your first 12 perfect squares. I hate memorizing, and I don't normally ask you to memorize, and I'm not asking you to memorize this list of numbers, but I won't say that it wouldn't be helpful for you to do that. That was a double negative. It would probably be helpful for you to at least be very comfortable recognizing these perfect squares. Again, I'm not going to tell you to go home and memorize them. I will never ask you to like write all of them down, but I would suggest being very comfortable with this list because you're going to be using them a lot. Okay, so before we get into non-perfect squares, let's just talk about our perfect squares. So square root of 16, 4. We don't have to include a radical. It is just 4. That's it. Number 2, let's just focus under the radical. So the square root of 121 is a perfect square. It's 11. And that 2 out in front just tells me I now need to multiply my answer by 2. 2 times 11 would be 22. Good. The square root of 289. It is a perfect square. It is in your list. So I'll give you a moment if you want to go back to your list and look at the list of perfect squares. But it is a perfect square. What is the square root of 289? It's 17. And then we want to take 17 and multiply it by 6. 6 times 17 is 102. And then our last perfect square, the square root of 400 is 20. 20 times 3 would give us 60. So our 4 answers there were 4, 22, 102, and 60. Now, let's practice a few more non-perfect squares. So 32. Again, you do not have to sit there and list all the factors, but I would at least go find them somewhere. So the factors of 32 are 1, 2, 4, 8, 16, and 32. So looking at that list, what's the biggest perfect square? Asa?
16.
Yeah, 16. So we have the square root of 16. And what do we multiply 16 by to get 32?
2.
Trey? Yeah, go ahead. No, you're good. Trey? 2. And then what we can do, since we have a perfect piece, we can take the square root of it. The square root of 16 is 4. And then we're going to leave 2 underneath that radical. So 4 root 2, or 4 times the square root of 2, or 4 square root of 2. That is what your answer would be. So let's try 180, and then I'm going to have you do one on your own. So again, this one has a lot of factors. So my advice is just look them up. I wouldn't list them. I'm going to list them, but there's a lot. So here we go. 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20, 30, 36, 45, 60, 90, and 180. It's a lot, okay? Again, not expecting you to write all of those, but you got to find them somehow, right? If we look at that list, I see a handful of perfect squares. I see a 1, a 4, a 9, and a 36. The largest one is 36. And if I couldn't figure out what times 36 gives me 180, work backwards. 180 divided by 36 is 5. 36 times 5 gives me 180. And what I can do is take the square root of that perfect piece, which is 6. Oops, didn't mean to draw that, which is 6. So my answer would be 6. And then underneath the radical stays the square root of 5. So 6 root 5 would be the answer. Okay, here's what I'd like you to do. I want you to try number 9. Number 9 says the square root of 48. When you're done, digital students, send me your answer in the chat, and you guys raise your hand when you're done with that one so I can come look at it. So square root of 48 is the one you're working on, is number 9. That's right, Selena. Try number 10 for me. and draw the root symbol for me. Yes, same with you. Yes. Yep, try number 10. On number 10, if you at least try to simplify the 54, do that. Yeah, try number 10. And if you actually want to take the square root of that, which would be what yeah, there we go. That's right, Didon. So try number 10, okay? Good job, Tatum. That's right. So try 10. Nihal, are you working on number 9? Square root of 48?
Yes.
Are you sure? Look at it more closely. 5 definitely is not a factor of 48. Did you hand up, Robert? Yeah. Okay. How am I supposed to tell? I don't know. Well, it's that. I can see it. Yeah, so try number 10. No. It's a good attempt, though. No. Wait, no, close. Oh. Okay. You know where you're working on 9, right? Oh, yeah, sorry. That's okay. Yep, close enough. You don't need to show me number 10. I just want to see number 9. We're going to go over number 10 together. No. Good try, though. Yeah, Nihal, that's right. The first one was right. Okay, so number 9. I think I've looked at most people's number 9. If I listed all the factors of 48, and I'm not going to, but they're 1 and 2 and 4 and 8 and 6 and 12. But the biggest square root that goes into 48 is 16. Specifically, good job, Malia, that's right. 16 times 3 gives us 48. And if we take the square root of 16, it would be 4. So 4 square root of 3 would be the answer there for number 9. Okay, so let's talk about number 10. A lot of you got started on number 10. Number 10 said 2 times the square root of 54. So let's just talk about 54. The factors of 54 are 1, 2, 3, 6, 9, 18, 27, and 54. I think that's it. The largest perfect square that goes into 54 is 9. So we would have the square root of 9 times, what times 9 gives us 54? 6. So we would end up with 3 square root of 6. But we cannot forget about the 2. Does anybody have any suggestion on what I could do to incorporate the 2 into my answer? Asa, what do you think we should do?
Multiply by 3.
Yeah, multiply by 3. Yes, Selena. Yes, Asa. Multiply 3 times 2. Yes, Tatum. So 3 times 2 would be 6. And then you leave the square root of 6 under the radical the same. So the answer would be 6 times the square root of 6, or 6 root 6 instead of 3 root 6. One common mistake, don't be this person, is some people want to take this 2 and also multiply it by the 6 that's under the radical. Don't do that. You just want to multiply the number that's outside. No, Selena, it would not be that. It would only be 6 root 6. So the last one I would like you to try, and let me know when you have your answer. Digital students, send me your answer, is number 13. 13 says -3 times the square root of 28. 13 says -3 times the square root of 28. Number 13. Oh, it's okay. But I think that's right for that.
Yeah, I see.
Oh, I see. So you got the underneath. So then what's 2 times that? Yeah.
So it's a correct.
No, because you got to multiply it by that number. You multiplied it by that for some reason.
Oh,
You see what I'm saying?
wrong.
Yes.
Okay.
Yeah. You start reminding me. Hold on. Oh gosh, so small. Yes, that's right. You can start working on your homework. Yes. Good job. What? What are you doing? Yeah, you're typing. Goodness, and glasses. That's right. Yes. I think you just didn't page this before. Yeah, that's right. You start working on your homework. Good job. Yes, sir. Good job. To fix it, Henry. Yeah, that's right.
So do I do the homework?
Yeah, you can start working on your homework with you. Did you simplify 28? Do that first.
Okay.
Simplify the square root of 28 first, and then we'll talk about what to do with that -3. Well, you don't have to, because 25 is a perfect square. When you get down, I think number 5, you can just hit that little math button over there and it has square roots in it. Yeah, the first 4 are perfect squares. So take the square root of 81, which is, and then multiply 9 times 7. Well, what's 9 times 7? Yeah. No, I want you to go over here. There's a square root button in there. Use it. I'll show you in a second. If you don't know where the square root button is for, hold on one second. If you don't know where the square root button is in Canvas, I'll show you on the board in just a second. Maybe? Yeah, that's what I'm talking about. Some people don't know where that is. Yeah. Bryce, I think that you had to take the square root of 4 first and then multiply by -3. I don't think you did that. Make sure you do that. So if you're in Canvas, oh, come on, buddy. Stop being a mean head. Oops. Hold on 1 second, Robert. I'm going to show everybody where the square root button is. So the first 4 problems are perfect squares, hence why you don't even have this option on the first 4 problems. But if you get down to number 5, you'll see a little button over here that has like an FX button. It's called Math Quill. If you click that, and let's say I want to enter the answer 2 square root of 5. So I would type a 2, and then I want to type a square root button, or we'll say 2 square root of 3. And then a 3, and then I click done. You'll see when it inserts into Canvas, it looks real weird, but that's okay. When it sends to me, it will send properly like you had it in the other window, okay? So I just want to make sure you saw that that was there. I would just type everything in the math tool if I were me, but that's fine too. Okay, beautiful. And then we want to multiply -3 times 2, and that would give you -6, and then you'd be done. Good job. Y'all may go to lunch. I'll see you after lunch. Digital students, again, make sure you send me your answer to number 13 if you haven't done that already. Okay, yeah.
So if you have your radical and it's like a number square root of the number, when you do the square root of that number, do you multiply it by the number? That's
Correct.
Okay.
Yeah.
Miss Simpkins,
Yeah, Bryce.
for number 13, can you tell me why -12 times
Yes,
the
it might be helpful if I write. Let me pull that back up on my screen. Okay, so what was the biggest perfect square you found for 28? That goes into 28. You're muted, Bryce. I don't know if you're trying to answer or not.
16?
So 16, does it go into 28 evenly? Update, it doesn't. So like what might be helpful is if we just list the factors of 28. So like the factors of 28 would be 1, 2, 4, 7, 14, and 28. All of those numbers divide evenly into 28. So what would be the biggest, what of that list, what's the biggest perfect square in that list?
4?
4, I agree. So we have 4. So that's going to be like our first square root. What times 4 gives us 28?
7?
Right. And so that's going to be like our other piece, our other radical. So what we can do is we can actually take the square root of 4. So what times itself gives us 4? What is the square root of 4?
2?
So we have 2, and then we have 7 underneath our radical. But for this problem, since we started with that -3, we have to then multiply -3 times 2 to get -6, and then that 7 stays under the radical. Does that make more sense?
Yes.